With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given that 17.4% of weight by volume K2SO4 solution at 27 degrees centigrade is isotonic with 5.85% weight by volume NaCl solution at 27 degrees centigrade. If NaCl is 100% ionized, then what is the percentage ionization of K2SO4 in aqueous solution? Right? So first of all, what is given? That weight by volume percent is given. So let us assume that 100 ml solution is there. 100 ml solution is present. So in 100 ml solution, what is the weight of K2SO4? So in 100 ml solution, K2SO4 is 17.4 gram and NaCl is how much? 5.85 grams, right? So this is the concentration in the 100 ml solution of K2SO4 and NaCl. Now what is said? It is said that isotonic, they are isotonic. What is isotonic? Isotonic means same osmotic pressure. Same osmotic pressure, right? This is what you mean by isotonic solution. So let's say pi of K2SO4 can be written as, pi of K2SO4 will be I into C into R into T. Now what is here I? I is the Van 't Hoff factor. Van 't Hoff factor. Right? Van 't Hoff factor. And C is the concentration. C is the concentration, that is molarity. C is what? It is molarity. So let us calculate first what is the value of I and C for K2SO4. So K2SO4 undergoes dissociation to give us 2K plus plus SO4 2 minus, right? And we know very well that I is given by the formula for, in case of dissociation, I is 1 plus n minus 1 into alpha, where alpha is degree of dissociation, right? Degree of dissociation. And what is n? N is number of ions formed, on dissociation, right? This is n, number of ions formed on dissociation. So you can write here I is equals to 1 plus, what is the value of n? Number of ions formed on dissociation is 3. You can see here n is equals to 3. So it is 3 minus 1 into alpha. Since we don't know the degree of dissociation of K2SO4, we will write it as it is. So the value of I will be 1 plus 2 alpha, right? This is the value of I. Now you can write down. Now what is the value of molarity? So for molarity, we all know molarity is equals to number of moles of solute present in 1 liter of solution. So you can say divided by volume of solution, if you are taking it in milliliters, then you need to multiply the numerator by 1000 to convert it into liter. So from here you can say that molarity of K2SO4 is equals to, what is the number of moles of K2SO4? So we have seen that weight is given 17 point, in the question it is given that weight is 17.4 grams. So we will take the weight as 17.4 gram. And what is the molecular mass of K2SO4? The molecular mass is 174. So weight by molecular weight is the number of moles into 1000 whole divided by volume of the solution, which is 100 ml. So in ml you need to take. Finally from here you will get the molarity of K2SO4 as, you can see from here the molarity will be 174 into 1000 divided by 1740 into 100. So from here you will say it is 1, right? Molarity of K2SO4 has come out to be 1. Now what is the molarity? Now you can write that pi of K2SO4 is equals to I into molarity of K2SO4 into R into T. So what is I? I is 1 plus 2 alpha, we have calculated for K2SO4 here, just here. And what is molarity? It is 1 into R into T, right? This is the value of pi of K2SO4. Now let's deal about NaCl. So NaCl on dissociation gives us Na plus Cl minus. Since it has been given that it is having 100% dissociation, right? So in case of 100% dissociation, it is given that NaCl is having 100% dissociation. The value of alpha is 1. So if value of alpha is 1, then you will write down 1 plus n minus 1 into alpha. So degree of dissociation is 1 and value of n here is 2 because two ions are formed on dissociation. So finally the value of I will be 1 plus 2 minus 1 into 1, which is equals to 2, right? So value of I is equals to 2 for NaCl. So for NaCl, value of I is 2. Now let's calculate the molarity. So molarity of NaCl will be number of moles of NaCl, right? Number of moles of NaCl divided by the volume of solution in milliliter. So volume of solution in ml, and you need to multiply the numerator by 1000 to convert it into liters. This is the formula. Now what is the number of moles of NaCl? So you have been given the weight is 5.85 divided by the molecular weight is 58.5 into 1000 whole divided by 100 because the volume is 100 ml. So from here you will find out that molarity of NaCl will be 5.85 into 1000 divided by 58.5 into 100, right? It will be 100 since it is given that the volume of the solution we have taken already as 100 ml. So from here you will get the value as 1. So the molarity will again come out for NaCl also, the molarity will be 1. So now you will write pi of NaCl, that is the osmotic pressure of NaCl will be the Ventov factor of NaCl into the molarity of NaCl into R into T, right? Temperature and R will be same for both the case. So what is I for NaCl? 2. What is M1 into R into T? So this is how you are going to write 2RT for pi for NaCl. Now since isotonic solution was mentioned, so isotonic solution, right? So isotonic solution means pi of K2SO4 is equals to pi of NaCl. So what is pi of K2SO4? We have already calculated pi of K2SO4 is 1 plus 2 alpha into R into T, right? And pi of NaCl just now we calculated it is 2RT. So on equating these two, you can write 1 plus 2 alpha. Alpha is the degree of dissociation of K2SO4. So 1 plus 2 alpha into RT is equals to 2RT. So from here, RT will cancel out from both sides. RT will cancel out from both sides and you can write down 1 plus 2 alpha is equals to 2. 2 alpha is equals to 1, or you can even write down alpha is equals to 0.5. So you can say the dissociation degree of dissociation of K2SO4 is equals to 0.5, or you can say that percentage degree of dissociation of K2SO4 is 50%, right? So this is only our required answer for the given question. As you can see in the question, it was asked that what is the percentage ionization of K2SO4 in aqueous solution? Since NaCl was 100% ionized, so you don't need to calculate for NaCl. We have already taken for NaCl alpha was 1 since it is given 100% ionized, but since K2SO4 was not 100% ionized, we have calculated that for K2SO4 the degree of dissociation is 0.5, and this is only our required answer. I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.